Hey everyone, so welcome to this video, and in this video we are going to discuss one more problem on bit manipulation, right? Bit manipulation. So the problem statement is you just given a number, let's say n, and you need to find out whether the ith bit of n is set or not. So here set means ith bit of n is 1 and unset means ith bit of n is 0. Okay. So we just need to find out whether ith bit of n is 1 or 0, right? So here we have two cases. Let me rub this. So case number 1 is ith bit of n is set, okay? And case number 2 is, let's say ith bit of n is unset, means it is 0, okay? So let's take an example. Let's say the number is 5 and 5 can be written in binary as, this is 5, okay, 101. So this is the binary form of 5, and here we have the first bit, sorry, 0th bit, this is the first bit and this is the second bit. And let's say we want to find out that whether second bit of 5 is set or not, okay, means this bit. So what we'll do, we'll take another number, that is x, this is x, okay, and the value of x is such that the ith bit of x is set, that is this bit is set, and rest other bits are unset. So this is 0 and this is again 0, okay. Now if we take AND operation of these two numbers, that is bitwise AND operation, so the result will be 1 0 is 0, 0 0 is again 0, and 1 1 is 1. So the result is positive, okay. So this is case number 1. Now in case number 2, let's take the number as 5, okay, and the binary form of 5 is 101. Now we want to check whether the first bit of 5, that is this bit, is set or not, okay. So in this case it is unset, right? So we'll take the number x, and here in this case the value of x is such that the first bit of x is set and rest other bits are unset, that is 0 and here 0, okay. Now if I take the AND operation of these two numbers, that is 5 and x here, so the result will be 1 0 is 0, 0 1 is again 0, and 1 0 is also 0. So here the result is 0, okay. Now let's take another example, okay. Let's take another number. So let's take 8. So 8 can be written in binary as 1 000, 1 000, and let's say we want to find out whether the second bit of 8, that is this bit, is set or not, okay. So we'll take x, and the value of x is such that the second bit of x is set and rest other bits are 0, okay. So this bit is 0, this bit is 0, and this bit is also 0. Now if we take the AND operation of these two numbers, so the result will be 0 0, this will be 0, and this is also 0, okay. So it is 0. And here if I take the same number, that is x, okay, sorry 8, same number, and the binary form of 8 is 1 000, okay. And here we want to check that whether 0th, 1st, 2nd, 3rd, whether the third bit of 8 is set or not, okay. So what we'll do, we'll set the third bit of x as 1 and rest other bits as 0. Now if we take AND operation of these two numbers, the result will be 1 0 0 0, okay. So it is positive, right? So what we can conclude from these two cases are, so let me rub this. So let's say we have any number x, okay, and another number y, or let's say we have any number n and another number is x, okay, and let's say we want to find out whether the ith bit of n is set or not. Now let's say if the ith bit of n is set, okay, so what we'll do, we'll create a number that is x in which ith bit of x is set and rest other bits are unset, okay, and if we take the AND operation of these two numbers, the result will always be positive, okay. And the case number 2, suppose if there is number n and if we want to check whether the ith bit of n is set or not, so let's assume that in this case the ith bit of n is not set, that is 0. So what we'll do, we'll generate a random number x in which ith bit of x is set and rest other bits are unset, okay. So in that case the output will always be 0 because the ith bit of x is set and rest other bits are not set in case of x, but in case of n the ith bit is 0, okay. So this and this will be 0, so that's why this will always give 0 and this will always give a positive result. So this is the whole idea. Now the problem is how to generate this random number x, okay. So if you have watched my first video of bit manipulation, then in that video I've explained the concept of left shift operator. So let's say this is any number x and here we have y, so this is left shift operator. Now its value will be x into 2 to the power y, okay. So let's take an example. Let's say if we have 3 here and this is the left shift operator, and if I write 2 here, okay, so its value will be 3 into 2 to the power 2, that is 4, okay, and 4 into 3, that is 12, right, it is 12. So using the concept of left shift operator we can generate this random number x. So let's say if in place of x, if I write 1 here and this is my left shift operator, and let's say if I write 2 here, okay, so its value will be 1 into 2 to the power 2, that is 4, its value will be 4, and 4 in binary can be written as 1 0 0, okay, this is the binary form of 4. So here you can see that if, let's assume that if the value of I is 2, okay, and we want to set the second bit of I, right, and the rest other bits will remain 0, so we can use this concept. Let's take another example. Let's say 1 and this is left shift operator, and let's take 3, okay, so the result will be 1 into 2 to the power 3, and that is 8, okay, it is 8, and 8 can be written in binary as 1 0 0 0. So you can see here that its fourth bit 0 first second third, sorry, its third bit is set and remaining all other bits are unset, okay. So we can make use of this left shift operator to generate this random number x, right. So let's see the code. So what I'll do, I'll create two variables, that is n and I, okay. So scene of n and I, and I'll take one more variable, that is x, and the value of x will be 1, then left shift operator and I, okay. So we just need to check whether the AND operation of n and x is positive or 0. So if n and x is positive, then we'll simply print ith bit is set, correct, and if it is 0, we'll print ith bit is not set, correct. So this is the code. Now let's compile this. Okay, so if I run this, so let's take the value of n as 5 and the value of I is 2. Okay, so it is giving this output, that is ith bit is set. So here you can see that ith bit is set means second bit is set for number 5. Now let's take another example. So let's say the number is 5 and if I take the first bit, so here you can see that the first bit is unset. Okay, so if I write 1 here, so the result is it is not set. Okay, so you can see that it is 0, right? So this is how you can code this algorithm, right? So that's it for this video. Thank you.